Hello students! Today we will be learning beyond our wild imaginations. I am Teacher Mario saying welcome to my class. So bear with me as we all explore the other side of the world of definite integrals. To start, let's have a review first. Consider this example. What is the antiderivative of x plus 1 dx evaluated from 2 to 4? To solve this, of course, we are going to find the antiderivative of the expression x plus 1. So what is the antiderivative of x? Is equal to x squared over 2. Okay. Plus, then how about the 1? The antiderivative of 1 is, of course, x. With the limits from 2 to 4. Next is we are going to substitute the upper limit then minus the lower limit. Since the upper limit is 4, so our equation would be like this. Let's substitute 4 to x. So it becomes 4 squared over 2, then plus x is 4, then minus. So, and we're going to substitute the lower limit to our expression. So it becomes 2 squared over 2, then plus x is 2. Next, we're going to operate. 4 squared, or 4 raised to 2, 16, over 2 plus 4. Then minus 2 squared is 4. Then over 2 plus 2. Next, 16 over 2, or 16 divided by 2, 8. Then plus 4 equals 12. Then minus 4 divided by 2, 2. Then plus 2 equals 4. Then 12 minus 4 is equal to 8. So that's it. So the antiderivative of x plus 1 dx evaluated from 2 to 4 is equal to 8. Okay. Now, we are going to use this concept in solving word problems involving definite integrals. So consider this situation or problem. The population of a certain town grows at a rate of e raised to 1.2t minus 2t people per year, where t is the number of year. At t equals 2, the town has 1,500 people. Question A, approximately by how many people does the population grow between t equals 2 and t equals 5? For question B, what is the town's population at t equals 5 years? So, how are we going to find or to solve these two questions? First is we're going to figure out A, or the first question. We're going to figure out this so that we can solve for letter B. If we are going to graph the given function, say f of x equals, which is the rate, e raised to 1.2t minus 2t. If we are going to graph this, the graph would be like this. Here's the y side, then here's the x side, or the x and y axis. The y axis represents the population, and the x axis represents the And if we're going to locate the time or the years, the given years, which is 2 and 5, okay, example here, and 5 will be here. Looking at this graph, this concept will be considered as a definite integrals. So, we're going to solve this with the help of definite integrals. So, through this graph, we can tell that the given problem is a definite integral. So, how are we going to solve this? How are we going to find the number or the population? What we're going to do is to find the area here. Area here. Okay, if you find the area here, then that means the population. So, with that, we can go to the integral form. So, we have the integral of this expression e raised to 1.2t minus 2t, evaluated from 2 to 5. 2 to 5 is the number or the years or the time, which is 2, the lower limit, and the upper limit of 5. So, to solve this is we're going to find the antiderivative of this expression. So, what is the antiderivative first of this e raised to 1.2t? Using the rules of the antiderivative, we can tell that this 1.2 or 1.2 is just equivalent to 12 over 10 or 6 over 5. So since 6 over 5, so using the rules of antiderivative, the antiderivative of this term is 5 over 6 e raised to 6 over 5 t, then minus the antiderivative of 2t is 2t squared over 2 or just t squared. So, then with the limit from 2 to 5. Next thing is solve. So we are going to distribute, we are going to substitute the limits 5 and 2 through this expression. So first we're going to substitute 5, then minus 2. So it becomes 5 over 6 e raised to 6 over 5. Then our t is the upper limit, 5, minus 5 squared. Then minus, for the lower limit, we have 5 over 6 e, 6 over 5. Our t here is 2, lower limit. Then minus 2 squared. Next is operate. 5 over 6. Next, e, cancel 5. So, the remaining is 6. Then minus 5 squared is 25. Then minus. Here, copy 5 over 6 e. Then multiply 6 times 2 is 12 over 5. 2 squared is 4. So we have, since we still have a parenthesis here, so let's distribute the negative to each term. So just copy this, minus 25, then negative times 5 over 6 is negative 5 over 6 e, then 12 over 5, or 12 divided by 5 is 2.4. Then negative times negative is positive, then copy 4. Okay. the next thing is we're going to combine. Since we have the common here, 5 over 6 and 5 over 6 here. And they both have e. So, 5 over 6, copy the common, then enclosed in the parentheses, the e raised to 6, and minus e raised to 2.4. Next is negative 25 plus 4 is negative 21, or put minus 21. So we have here 5 over 6. Then what is this equivalent to 403.43. Then minus e raised to 2.4, it is equivalent to 11.02. Next is minus 21. Next, 5 over 6, copy. 403.43 minus 11.02 is 392.41. Then minus 21. Next is multiply 5 times 392.41 divided by 6. The answer is 327.01. Then minus 21. 327.01 minus 21 is equal to 306.01, and it is approximately equal to 306 people. So there are, in the range from 2 to 5 years, there are 306 people. The number of population here is 306. So that is the answer for the first question. And for the second question, as I mentioned earlier, that we're just going to add the answer of the first question, then add it to the initial population, which is 1,500. So our initial population is 1,500. Here, 1,500, then plus 306 was 1,806. So there are 1,806 people after 5 years. So for now, I will give you another example which can be solved by 2 or by pair. So choose your buddy. Another problem. It takes a force of 10 Newton to stretch a spring 2 meters beyond its natural length. How much work is done in stretching the spring 4 meters from its natural length? First, do you know what spring means? It's not the weather or the season. It's an object just like this. Since it is by pair, so the only thing you have is to discuss and brainstorm with your partner all the ideas you have. To understand better, consider this illustration. Okay, this is the spring, the original in natural length. If you stretch it with a force of 10 Newton, the length now will be 2 meters. So it looks like this. Okay, that's 10 Newtons. And its distance is, its length is 2 meters. And that's the given. And the question here is, how much work is done in stretching the spring 4 meters from its natural length? So that means that how much force you will exert so that the length of the spring will be 4 meters. So it looks like this. Okay. it's 4 meters. And the force is ano? Newton. Okay, so the only thing we are going to do is to solve this. Okay, clue. The clue is you're going to use the Hooke's law, and the answer is 40 Newton. The only thing you should do for now is to derive or show your solutions to arrive at that answer, which is 40 newtons. Okay, you have 5 minutes to answer. Are you all done? Okay, can someone show their answers on board? It's correct. By Hooke's law, which is f of x equals kx, since we can use a force of 10 newton so that the length of the spring will be 2 meters. So we have here the 10, which is the 10 newtons, and we have k times 2, we have 2k, and so we get k equals 5. So our function is f of x equals 5 over x. Then, now we will proceed to the integral. We're going to find the antiderivative of 5x dx evaluated from 0 to 4. So we have here, and we're going to find the antiderivative of 5x. So we have 5x squared over 2 with the limits from 0 to 4. And next is we're going to substitute the upper limit minus the lower limit. So we have here 5 times 4 raised to 2 over 2, then minus the lower limit, 5 times 0 squared over 2. Compute this, 5, compute first the 4, 4 squared is 16, so we have here the 16, then copy 5 over 2. Then we have here 0 squared is 0 times 5 is 0 divided by 2 is 0 still, so minus 0. So we have here cancelled 16 over 2, we have 8, then 5 times 8 is 40, minus 0, so still 40. So it needs a force of 40 newtons so that the length of the spring will be 4 meters. So for now, I will give you another activity, an individual activity. By the way, you can ask your classmates for assistance if you have any. Are you done answering, class? Okay, since you are done answering, I will call someone to show their answers to the class. Okay, write your answers. The answer. Okay, very good. All the answers are correct. So for number 1, the answer is 76.8 miles per hour. Thus, the velocity of the car after 8 seconds is 76.8 miles per hour. And for number 2, the answer is 0.068 miles. Therefore, the car traveled 0.068 miles during those 8 seconds of acceleration. So, you have learned today, how do you find solving problems involving definite integrals? Is it interesting? Yes, of course, it is interesting, definitely interesting, but at the same time, very challenging. So with that, I have here an activity sheet for you to answer. Okay, read and understand carefully the problem and then solve. Okay, are you all done answering? Okay, so submit your output now. Thank you, class, for your cooperation. Class is dismissed.